Okay, in today's lesson, we're going to learn about this concept called combinations. The other day we talked about permutations. Now we're going to add to this concept of combinations, and we want to understand today the difference between the two when we use permutations, when we use combinations, and then we're going to learn how we can count different kinds of combination events. Okay, quick review. The other day, we talked about permutations. When we have n objects, we can reorder them in n factorial different ways. Order matters. That's the key thing. This is the key word for permutations. Order matters. So I'm going to actually highlight these things. So if I want to rearrange the letters of A, B, C in different ways, there are 3 factorial ways to arrange these 3 letters. If I wanted to choose a subset of that, R objects out of N objects, then there are what we call NPR, N permute R, or N pick R, N factorial divided by N minus R factorial, different ways to arrange, where order matters, R objects out of N objects. Now sometimes we might want to rearrange N objects, and so instead of just being n factorial, we have some repeated objects. When we have repeated objects, then we need to divide away the repetition, because say we have 3 letters that are all the same letter, A, and A. In that case, we'd want to divide away 3 factorial because all of those different letters look exactly the same. So if we had 5 scoops of ice cream, and 5 flavors to choose from, and order matters here because I'm eating from the top down. There are 5 factorial different permutations of 5 scoops of ice cream chosen from 5 flavors. But now if I'm choosing from 12 flavors instead, I use this concept of permutations, 12 permute 5. In this case, that's 12 factorial divided by 7 factorial. And we could actually think of it as 12 times 11 times 10 times 9 times 8. 12 ice cream flavors to choose from for the first scoop, then 11, then 10, then 9, then 8. These are equivalent ways of writing it. Okay, order mattered with permutations. In combinations, order does not matter. That's the key thing here. Combinations, order does not matter. So, ice cream again. Let's look at ice cream, but in the context of a bowl. When we have a bowl of ice cream, order does not matter. It's all, I could eat the strawberry, then I could eat the, grape. It's all in a bowl. Doesn't matter. So if I want to choose 5 scoops of ice cream from 12 flavors, if order mattered, then I would have 12 factorial divided by 7 factorial, which is my 12 pick 5. But in the case where order does not matter, we need to divide out the repeated cases. What do I mean by the repeated cases? Well, say this bowl of ice cream, there's 5 scoops here. It doesn't matter what order these are in. If I were to order it, there are 5 factorial ways to order 5 scoops. But I don't care about the order, so I'm going to divide that away from this total choice here. So the denominator is where order matters, and I'm dividing away the repeated cases here. So we end up with this statement 12 factorial over 7 factorial. Let me just highlight that part of it. So the yellow here, these are the same thing, and then we have the 5 factorial where we're dividing out the repeated cases. So in this case, instead of 95,000 different ways to order 5 scoops out of 12 flavors, I only have 792 ways to choose 5 scoops out of 12 flavors when order does not matter to me. Now, just like we have a shortcut way of writing permutations, we have a shortcut way of writing combinations as well. Again, we use this NCR type of notation, which is NPR divided by that dividing out of the repetition. And NPR was equal to this, if you remember from the other day. And then now we divide out this r factorial in addition to that. So let's look at a specific example. From a team of 12 basketball players, we want to choose 5 players to start the game. Order doesn't matter in our basketball team. So we use this combination, 12, choose 5. I'll use the word C here, or choose for C, just as a way of speaking it. 12, choose 5, which is 12 factorial over 5 factorial times 7 factorial, and this is equal to 792. Now, let's talk about where we might have multiple events that we want to count. Sometimes when we have multiple events, we multiply the two counts together. So let's look at this example. I have a bunch of movies, 12 comedies, 8 action movies, 5 suspense movies, 9 family movies. But I only want to choose some of them. I want to choose 2 comedies and I want to choose 3 family movies. So how many possible ways of selecting those movies are there? Well, if I were just to think about the comedies, I have 12 comedies and I want to choose 2 comedies from them, and I don't care about the order here, so I have 12, choose 2. But I have this word and. I want to also pick 3 family movies. How many ways are there of picking family movies? Well, I'm going to multiply because of the and I'm going to have 9 choose 3 as the number of ways I can choose 3 family movies out of 9. Okay, so the key idea here, the key concept is we multiply when we have an and. So I have 2 kinds of things I want to count. I want to count the comedies choices, and I also want to count the ways I can choose family movies. And because I'm looking at the and here, I want to choose both 2 comedies and 3 family movies. We multiply those 2 counts together. And that equals, in this case, 5,544. A slightly different case is when it's an or type of thing. I want to count the number of ways I could do A or B. Let's look at something here. So I decide to watch at most 2 movies. Breaking down the English a bit, when you see words like at most, we want to rewrite that. We want to write that as 0 or 1 or 2 movies. Because it's hard to think about it, as a phrase of at most. It's easier to break it down, to count how many ways can I watch 0 movies, or watch 1 movie, or watch 2 movies, because that satisfies the at most 2 movies are being watched. Well, let me count up how many movies I have. I have 34 total movies. 12 plus 8 plus 5 plus 9. So out of 34 movies, there are 34 choose 0 ways of watching 0 movies. And then I'm going to add that to the number of ways I could choose 1 movie, so that's 34 choose 1. And then I'm going to add that again to the number of ways I can choose 2 movies. That's 34 choose 2. So the key concept here is when we see the word or, we associated that with adding counts. So if we figure this out, the ways to choose 34 movies out of, or the ways to choose 0 movies out of 34, there's only one way. I don't watch anything. The number of ways to choose 1 movie out of 34, well, there's 34 movies, so there's 34 ways to choose 1 movie. And then the way to choose 2 movies, there's 561 of those, for a total of 596. Okay, here's some problems you can work on your own. One last concept. This is the concept which is important, which is called counting by subtracting from a total. So let's highlight that part. Subtracting from a total. So let's take an example. A magazine has 11 articles. I want to read at least 2 of them. So 2, 3, 4, 5, maybe all 11 movies. Or not movies, articles. How many combinations of articles can I select to read? One method is kind of what we've already done before in the previous example. I can watch, actually we need to correct the notes a little bit. I can read 2 articles. That would satisfy at least 2, or 3, or 4, or 5, all the way up to 11 different articles. So let's break this down. How many ways are there to choose 2 articles from 11? Where order doesn't matter. I don't care what order I read them. So out of 11, I choose 2. And then we continue on and we add to this the number of ways we can choose 3 articles from 11, 4 articles from 11, 5 articles, and so on, all the way up to choosing 11 articles from 11 things. So this is a legitimate way of solving the problem. We just have to add all these different terms up together, figure them out one by one, and add every single one up. A different way to approach it is to take it from the reverse way. We say, well, what would be the total number of possible ways I could read any of the articles? Reading 0 articles, reading 1 article, reading 2 articles, all the way up to 11. How many different possible ways are there? And then subtracting away the number of ways I could only read 0 or read 1 article. So let's talk about the number of ways I can read all of them. So consider this. I have 11 possibilities, 11 articles. I can read it or not read it. So there's 2 choices for each article, read or not read. So I multiply 2 times 2 times 2 all the way down, and I get 2 to the 11th power. That would be the total number of possibilities. Again, for each article, I have 2 choices, either to read that first article or not read it. For the second article, 2 choices, read it or not read it, all the way down to the 11th article, read it or not read it. So there are 2 to the 11th different possibilities there. Okay, now I'm going to subtract away the number of ways out of 11 articles I can choose 0, minus the number of ways out of 11 articles I could choose 1. So this is the same as this other one over here. It's just less work. So I can calculate this. This 2 to the 11th is 2048. The number of ways to choose 0 things out of 11 is only 1. The number of ways to choose 1 thing out of 11 is 11. I didn't even need a calculator for these 2 things. And then I could calculate the total, 2036. Okay, so key lesson of today, combinations is used when order does not matter. Order does not matter. That's the key thing for today.